Hi, doing a quick little video on chapter 2.3, trig derivatives. So here we go, trig derivatives. Derivatives of trig functions, excuse me. So let's recall some of the basic functions that we have and their derivatives. Sine of x, the derivative of sine is cosine of x. Cosine of x, its derivative is negative sine of x. Tangent of x, derivative secant squared of x. Cotangent x, negative cosecant squared of x. Secant x is secant x times tangent x. And cosecant x is negative cosecant x times cotangent x. Make sure you have that list written down. We're going to need it quite a bit. All right. As we go through and we work on some of these problems, we might have to find specific values. So we want to go back and look at our reciprocal functions to understand how we can utilize sine, cosine to get these values when we're dealing with the unit circle and so forth. So recall, secant of theta is equal to 1 over cosine of theta. Cosecant of theta is equal to 1 over sine of theta. Tangent is 1 over cotangent, but recall it's also sine over cosine. So a couple little things there. Cotangent is 1 over tangent. So the reciprocal, again, cosine over sine is cotangent. Now we've got some Pythagorean identities that we can utilize to help simplify. So we have sine squared theta plus cosine squared theta is equal to 1. Then 1 plus cotangent squared theta is equal to cosecant squared theta. Tangent squared theta plus 1 is equal to secant squared theta. All right, let's see how we apply some of this stuff. Example number 1, 3x plus cotangent x. Find the derivative. All right, so basically this is not a product rule. It's not a quotient rule. We just have f of x and g of x separated by a plus sign. So we can just take the derivative of each one, which makes it nice and easy. Y prime, the derivative of 3x is just 3. Cotangent x, well, the derivative of cotangent, as we just saw, is negative cosecant. So we put the negative cosecant squared x. And so our y prime is just 3 minus cosecant x. All right, our next example. Let's go over here. All right, our next example is right here. Y equals x cubed secant x. Well, in this case, we do have a product rule. So what we want to do is utilize f of x times g prime of x plus g of x times f prime of x. Make sure this is in your notes. We're going to need this quite a bit from here on out. So f of x, I've color-coded this here for us so we can hopefully follow along. F of x was just x cubed. The derivative of secant or g prime of x was negative secant x times tan x plus regular f of g of x, which was secant of x, and then the derivative of x cubed is 3x squared. Simplify that. We have an x squared that we can pull out. I've underlined those two. They're the same. So we have something in common there. And we have something where this secant is in common. So I've decided to pull out a negative x squared. So secant x altogether, negative x squared secant x. What that leaves me on the inside is I'll have one of the x's that's left over here. That's that. The tangent, there's the tangent. This plus changes to a minus when we factor out a negative. And that x squared goes away. So I'll be left with x tangent minus 3. And that is your final answer. All right, last one. A little bit more of a challenge. Hopefully you can follow this on the board. I'll try and walk you through it and keep everything else covered as much as possible when we can. So it says y is equal to cosecant x over x squared. Now, and it says find the position at pi over 6. So that means what I've got to do is I've got to initially plug in pi over 6 for all my x's. It's just like if we have a curve and my angle is pi over 6, my x value, where will that y value be? What's the value going to be? So f of pi over 6, well, it's the cosecant of pi over 6 divided by pi over 6 squared. So I haven't taken any derivatives. This is just the position now. So the cosecant, let's see, I'm going to come over here. Cosecant is 1 over sine. Cosecant of pi over 6 is 1 over sine of pi over 6. Right? Makes sense? Well, the sine of pi over 6 is 1/2. If I take 30 degrees, pi over 6, the sine is opposite over hypotenuse, and that's 1/2. Hopefully it's big enough for you to see. 1/2. Now, since cosecant is the reciprocal, then the cosecant of pi over 6 is 2 pi over 1. All right, so hopefully I was able to walk you through that. You can rewind it if you need to and check it out. So let's fill in some information. Cosecant pi over 6, well, that was just 2. Then we have pi over 6 squared, which is pi squared over 36. When you have a numerator multiplied or divided by another fraction, then we can flip and multiply. So our final answer of f of pi over 6 is 72 over pi squared. Okay, now the big part is when we want to find the slope at pi over 6. So we have a situation at g of x times f prime of x minus f of x times g prime of x all by g of x squared. This is going to require the quotient rule. Yes. So our g of x is x squared, right? G of x. Our f prime of x, the derivative of cosecant, is negative cosecant cotangent minus, inside here, f of x is cosecant x times 2x. That is the derivative of x squared, 2x, all divided by x squared to the second power. All right. Now, what we have here is, I can get this thing scoot over a little bit, negative x, cosecant x. I brought out an x and a cosecant x from here. Okay, I want to pause the video, write everything down, check it all out for right now. And then we're left with x cotangent x plus 2 over x to the 4th. The next piece is here, negative cosecant of pi over 6 times x, which was pi over 6, times the cotangent of pi over 6 plus 2, divided by pi over 6 cubed. Well, that's because there was an x here, and I took it out, and I eliminated that for now. We know that cosecant of pi over 6 is 2, and cotangent of pi over 6 is root 3. Cotangent is adjacent over opposite, so we get root 3. So plugging those numbers in, we get negative 2 times pi over 6 times root 3 plus 2 all over pi cubed divided by 6 cubed. And then finally f prime of pi over 6. Hopefully you can see this. I don't know if it's big enough. I might have to bring it closer, but we get negative pi over 3 times cube root of 3 minus 4 times 6 cubed all over pi cubed. I encourage you, stop the video, turn it around, check it out. It's pretty crazy. That's a long one, but I think it's right. So there you go. Have a great night. Talk to you soon.